Now let me show you some coding example that how we are developing the developer mindset. Here I am not going to show a full demo of the code, but I am just going to explain a couple of codes that how we are doing this. And developing this developer's mindset is extremely important for machine learning nowadays because many students are coming from non-computer science or non-mathematics background. For them, developing a code is really intimidating, and sometimes there is a lack of confidence, and that as a instructor you may need to overcome. You may need to help the students to overcome that mindset. So that's very important, and not only for the non-computer science major student, even the computer science students are also sometimes confused regarding the machine learning codes, because whenever they search in the internet regarding some kind of codes, they get a huge amount of machine learning codes, but all of them are full of noise. For example, like a student wants to learn, let's say, a neural network, and the students end up in some ABC company's website. That company has some unique data set for which the data wrangling is really very complicated. They have employed several statistical techniques and all these things to do the data wrangling, and then build a very complicated neural network model. The students, as a beginner, it is very hard for them to realize that, well, this is not the basic machine learning code, and it may not work for all the data sets. So it is very important to extract the fundamental project workflow of machine learning and very carefully craft all the codes to teach them how to become productive and how to develop a machine learning model by their own. And if the student is so many times I have seen among my students that they are a little lost after surfing over internet. They come to my office and always they say that, all right, I'm not really sure what this code is doing. This code is running perfectly fine, but I am not sure what to do. So in order to overcome this barrier, we have carefully crafted a lot of different codes after discussing with the engineers and scientists and developers from Facebook, Fidelity, IBM, and multiple different companies. We have developed all these codes. So let me show you a couple of examples that we have created. So here, as you can see here, it is a code for neural network with scikit-learn. And as I have told, we have extracted the fundamental pipeline of machine learning code, which consists of, like, let's say, what type of data it is, whether you need to download the data or you can load the data internally from your machine, and how to load the data, how to load the data set from a file, and all these things, what format the data is available, how to explore the data and do all the data wrangling, such as scaling, splitting the data into training and test set. All these fundamental steps, we crafted this code very carefully so that a beginner student can easily understand. And then we start teaching them how to initialize or create a machine learning model, and how to train the model, and do the prediction and evaluate it on the test data. So as and all the other different types of plots like confusion matrix, etc, etc. So as you can see in this code, we start from the very beginning. We do not assume any type of prerequisites that the students know how to download the data and how to feed the data in the machine learning model. No, we do not assume that. We start from basic, how to download and how to load the data, and how to do the data wrangling, and how to build a model and evaluate the model. So each step we teach them very carefully, and all these codes are designed in such a way so that the students can easily modify based on the instructor's feedback and all these things, and learn much better machine learning. And not only for psyche to learn, sometimes as a machine learning professional, the students need to try out many different tools, because because of the implementation of the tools. Some tools have better performance, some tools even show better accuracy even for the similar type of model. And of course, some of the tools have some extra facilities that the students may need to learn, something like that. So trying out different some same tools in many different same model in many different tools is extremely important nowadays, be it for the performance, be it for the accuracy, be it for the robustness and everything. So what we have done, we always teach the students with the similar machine learning model with many different tools. For example, this tool is a neural network with scikit-learn, and we have the similar type of implementation of neural network with PyTorch. And also we have the similar type of implementation of neural network with TensorFlow. And all we try to, and the mindset that we develop in our students is like, well, most of the phases of the machine learning project workflow or machine learning project pipeline are kind of similar, starting from how to get the data, load the data, data wrangling, exploring, scaling, splitting. Most of these things are same. And while teaching them that, we teach them about pandas, numpy and all those tools also, instead of just teaching TensorFlow or something like that I have mentioned earlier. Anyway, and also we show them that, well, these steps are same. The main difference comes when you start working on these models, like initializing or creating the model, training the model, and how to predict the model, how each model trains in a different fashion, what are the technical difference and all these different things. So so we have the codes for these popular tools, like this is the code for PyTorch, and also the similar code we have implemented for TensorFlow. So all we are trying to do in our students is like, well, machine learning is not really very intimidating things, because when a new student comes to learn machine learning, the first thing they see that, well, I need to do a lot of mathematics, oh my god, how to do that? And well, after learning the mathematics, they are just in an ocean of codes, and most of the codes available over internet is full of noise. So the next barrier is, oh well, I cannot make out the code, so what will I do? So these type of, and in the near future, eventually what happens, they just starts feeling in a lack of confidence, and most of the time what happens, they kind of well go with the existing code without learning. So in the end, their learning needs are uh, not quite satisfied. So those are the subtle things that we always keep in mind, and based on that we very carefully craft our coding examples as well as our online platforms and tools to develop the developer's mindset. So our end goal at Onstitute is to develop multiple AI, ML, and deep learning, I mean, artificial intelligence, machine learning, and deep learning curriculums. And finally, and also we want to develop some kind of model zoo. We are already doing that, but we want to extend it at a very huge level. So here is an Here is an example of a model zoo that I have already discussed. I have already shown the demo. So here is, as I have told, like we developed a similar model with with all the popular, different popular tools such as scikit-learn, PyTorch, TensorFlow, which are easily available to the students, and our codes are very carefully crafted. So our end goal is basically create an ONNX like model zoo, but specifically for educational purpose, so that the students, even from the non-STEM major students, they can learn machine learning in a nice fashion and their learning demands is satisfied. So here is the conclusion. So we basically would like to continue our collaboration with our existing collaborators, so which are Facebook, Fractal, Fidelity, IBM. They are the company collaborators, and our in university collaboration is also increasing. That includes Technical University Delft, U Oregon, University of Alaska Fairbanks, and in India we have collaboration. We have offered our courses to SRM Institute, Gujarat Nirma University, and we are always open for collaboration. And if you want to adopt a course in your university, or if you want to improve the course by introducing a short 10-hour course in your existing curriculum, or if you want to organize workshops or hackathons or guest lectures, you can contact us and we are always happy to help you. I can give you some example. For example, a few months back, we have worked with Nirma University in Gujarat and offered a course on open power and computer architecture, which is very important for nowadays, uh, which basically covers the big data analytics hardware part. And there we have collaborated with the Kent State University, and an NSF Career Award winner faculty member taught a short 5 hours course and short 10 hours course, and we have and the students were very happy about that. So if you are also interested on something like that, let's say you have an nice existing course but you want to improve it even more with lots of hands-on experiences or some different perspective or some modern examples or something like that, feel free to contact us and we will be happy to help you, and we'll be happy to work with you. And also, if you have some kind of research idea and if you want some access to some high performance computers or some of our tools, or if you something like that, please contact us. And if your student is asking needs some kind of project works to and mentored projects and all these things, for that also we will be happy to collaborate. So if you have any type of ideas in mind or any questions or concerns, please let us know. We will be happy to help you, and we are always open for collaboration. So that is all from my side, and I would like to thank everyone for watching this video in today's conference. And now I'm open for question and